Hello year ones, I'm Claire and we're going to review all that we've learned about numbers and counting. You'll need something to write with and something to write on, like a paper and pencil. You can use your sticky notes or you can use your scrapbook, and you can record lots of things in your book during the lesson or afterwards, just like I've done. I've been recording something that we've done every day. Do you remember when we did our 10 facts by making a rainbow, and we wrote out those 10 facts and we noticed something? Or did you notice? When you look at 0 and 10 is 10, so is 10 and 0. When you look at 1 and 9 is 10, you can also see 9 and 1 is 10. So the rainbow works forward and backward. Forward and backward. 2 and 8 is 10, and 8 and 2 is 10. Did you notice that pattern? I bet you did. Very good. So the learning intention of this lesson is to review all of our strategies. We're going to try subitizing 10 frames, we're going to use our 100 chart, and we're also going to look at tens and ones again so that we remember all the things we've been doing, because we have been doing a lot of things about number in the last few lessons. We've been talking about the ways you count. We've been looking at the patterns in the hundreds chart. We've been practicing those counting principles by counting collections of things we found around the house. We have estimated, and then we have checked by counting. We've made sure our estimates are getting closer to the total. Because remembering, we've been noticing estimates that are too high and estimates that are too low. And we've been getting estimates that are closer to the total when we check by counting. We've learned about efficient counting. Sometimes it's much quicker to count in 2s or 5s or 10s, depending on what you're counting on. We've also learned about subitizing. That's really super, isn't it? Because you can sometimes tell how many at just a glance. And we've been practicing subitizing using dice, dominoes, and even playing board games that have got dice and numbers on them, like the snakes and ladders. We've also learned about different representations of number, and we've made some Y charts so that we can record the number name, the number, and then use dots to represent that number. Another representation we've done has been the tens and ones chart. So we have looked at a number and we have asked how many tens in that number and how many ones, and we've represented the number on a tens and ones chart. We've learned lots of new mathematical words, and we have been recording them in the back of our book. Now you may have been recording them on a piece of paper. My list is getting longer and longer. What's your list looking like? Are you remembering to write down the words that we're learning to do mathematics? Good. Now, what have you done since the last lesson? Perhaps you made your own number lines. What number did you start from? Perhaps you estimated a collection between 20 and 50 and recorded them on a tens and ones chart. Or maybe you recorded your number on tens frames, remembering that you might need more than one tens frames. One 10 frame records the number up to 10. When it's full, it's 110. Two tens frames can give you 20, and 3 can give you 30. So if you're recording a number that's in the tens, you need to have more than one 10 frame. Are you really careful now when you say the numbers, especially those ones that look alike, like 13? Can you write that down right now? 13. What does it look like? Which number comes first? 13. It's really important that we write these numbers in the right direction, because when we write a number like 13, we have to remember it's 110 and 3 more. The 3 more are in the ones column. So when we put it onto our tens frame, a 13 looks like a 1 and a 3. But the other word that I'm confused with that one is the word 30, because it sounds very similar, but it's a very different word. So if we look at that one, it's 30. And that means something very different when it comes to tens and ones, doesn't it? It means we have 3 tens and how many ones? 0. You're correct. 30. Look, we have another 30 up there. 30. 3 and no ones. 3 tens, no ones. 30. You may have to do this yourself for 15. Let's see if you can do 15. How many ones? How many ones? 5. How many tens? 1. 1 10 and 5 more is 15. Can you please record that on your tens and ones chart now? Good job. Good job. Not to be confused with the one that looks like this. Sounds very similar, doesn't it? 15 and 50. But 15 has only got 1 10 in it, whereas 50 has how many? That is correct. 5 tens. How many ones? No ones. No ones. So let's have a look at the difference between those two. We have 5 tens and no ones. The 0 holds the place for the ones. But when we look at 15, we've got 1 10 and 5 ones. 10 and 5 more makes 15. Those are tricky numbers. You have to really be careful of them. How about you try now doing 16 and then 60. 16 and 60. Can you put them on your tens and ones chart? And I'll do the same up here. So you're doing it quietly and I'm doing it quietly. I'm not going to say anything. Are you finished too? Me too. All right, I know that 16 is 1 10 and 6 ones. That means 10 and 6 more. And 60 is 6 tens and no ones. So we put the 6 in the tens column and the 0 here to hold the place for if there were ones, but there are no ones. So it's got a 0 in there. All right. Very well done. This is one of the many strategies we've been using to look at numbers. Now, when we were counting collections, do you remember we counted all my children's beanie kids? Do you remember the beanie kids? They all look like this. And we counted the collection. I can't remember how many. I wonder, do you remember how many? We estimated before, and then we recorded how many we thought there would be. Then we checked by counting, and we saw how close we came to our estimate. So let's do that again. Here's our beanie kids, big bag full. Can you estimate how many beanie kids are in there? I remember the first time we did this, someone said there were 1,000 in there. 1,000! I know there's a lot, but do you think 1,000 was a good estimate? No, not 1,000. So some other people thought there were 6. 6. Is that a good estimate? No, too low, isn't it? So we're learning to estimate and try and get close to the total. So let's estimate how many there are in there. Let's say, I'm going to say, I think there's about 26. Shall we count them in twos? Would that be the most efficient way? I could count them in ones, but that would take longer. Efficient is when things are much faster and easier. So I'm going to do the efficient way and try and count them in twos. Oh, yes, someone said I could count them in tens, but actually in this case that might be a bit inefficient because there's so many of them, I'd have to make them into groups of 10 first. Not like the counters, which are already in groups of 10. I can count these in 10 very efficiently. Can you see that they go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Were you helping me with that one? Thank you. Now, back to the Beanie Kids. We're not counting them in tens because they're not in groups of 10. We're going to count them in twos because I can take them from the bag 2 at a time. Are you going to help me? All right, let's go. Now bring the bag a bit closer. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, I was right about the 20 bit, wasn't I? 22, 24. That's all the Beanie Kids. 24 Beanie Kids. And I remember I estimated 26 Beanie Kids. So my estimate was quite good, wasn't it? I was close. That's what you want to be when you estimate. Mathematicians even sometimes get it exactly right. I didn't get it exactly right this time, but I was quite close. And estimates do not have to be exactly right, but they do have to be close. Let's write down how many we have. What was our total? Do you remember? The total was 24. 24 Beanie Kids. That's a lot of Beanie Kids. I wonder, can you remember how to represent that number on a 10 frame? Can I use one 10 frame? Do I need 2 10 frames? Or do I need 3 10 frames? What are you thinking? Someone said 2. Let's see, what would 2 10 frames? How many spaces are there in the 10 frame? 10 and 10 more. What would that get us to? That would get us to 20, wouldn't it? 20. Well, there is a 20 in my number, but there's some more, isn't it? So how many 10 frames do I need because I need more than 20? You're correct. I need another one. So I need to represent, I need 3 10 frames to represent 20 and 4. 2 10s and 4 1s. Let's see, can I do that now? Let's put them over here. 2 10s and 4 1s. Luckily, I have my, remember I counted these in 10s, so I know there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll need another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many more? Do you remember the number? It was 24. I have 10, 10 more, and 1, 2, 3, 4. 24. All of those teddies are represented by 2 10s and 4 1s on my 10 frames. 24. We can represent the teddies by the number 24. We can represent them on 2 10s frames and 1 more with 4 1s. We can write it into a 10s and 1s chart. How would we do that? We have to write a 2 in the 10s column and a 4 in the 1s column. 24. If I look at my 100 chart, where will I find 24? Where will I find 24? Do you remember that these are all the 1s and the 10s start here, and here's the start of the 20. I need 4 more, so 21, 22, 23, 24. There's 24. 24 is 2 10s and 4 1s. Well done. All right, to practice all our different strategies, we're going to play a game. This game is called Magic Bean Toss. But I'm not using beans today. I've taken some dry pasta. It's going to be a great game because you have to estimate, you have to record, you have to throw dice, you have to sabotage, you have to count, you have to arrange, and you have to count again. All right, so what I'm going to do is I'm going to throw the dice, I'm going to sabotage how many, and then I'm going to grab the beans. All right, are we ready? Set, go. Okay, sabotaging. 6 and 4 is 10. Now I'm going to count the beans. 2, 4, 6, 8, 10. Throwing it again. How many have I got? 5 and 5. Double 5 is 10. 2, 4, 6, 8, 10. Okay, going to do it again. I'm sabotaging. 1 and 1. Double 1 is 2. And I take 2. One more time. Ready? 2 and, oh, double 2. It's 4. 2 and 4. All right. That's a very clever game. And what you're doing is you're going to see how many of the beans you can get out in 1 minute. All right. So you record your estimation first. I did not get very many in my minute because I was just showing you how to do it and I had to show you how to sabotage. Let's see how many I got. I'm going to count them in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. I got 27. I think you should play this game at home. So, set a timer for a minute, get a big collection of things, estimate how many you'll get in 1 minute, record that estimation, throw the dice, sabotage the numbers, pull out that many beans, and when the 1 minute timer finishes, count how many you've got and see if each time you play, you get closer to your estimate. We've learned so much over the last few weeks. I hope you'll enjoy practicing all we've learned by playing the magic bean toss game. I'll see you next time. Bye.